Today on the John Ankerberg Show, how does the scientific discovery that the universe had a beginning point to the existence of God? How did the work of Stephen Hawking reinforce the conclusion that the universe had a cosmic beginning? We will also critique his attempt to find a different beginning via quantum cosmology. And what led astronomer Edwin Hubble to discover that the galaxies, and indeed the universe, was expanding in all directions of space? How did Hubble realize that as the galaxies receded away from us, the faster they were moving away, this implied something like a spherical expansion of the universe? It was like a great balloon being blown up. But then he also came to realize if you wind the picture of the universe backwards in time, at any finite time in the past, the universe would have been smaller and smaller and smaller. The galactic material would have been closer and closer and closer together. And eventually, you would get to a point where you couldn't back extrapolate any further, where everything would have converged to a point that marked the beginning of the expansion and indicate the beginning of the universe itself. My guest today is Dr. Stephen Meyer, who received his PhD in the philosophy of science from Cambridge University in England. And his book, The Return of the God Hypothesis, is a USA Today national bestseller. We invite you to hear this special edition of the John Ankerberg Show. Welcome to our program. I'm John Ankerberg, and my guest is philosopher of science, Dr. Stephen Meyer, who received his PhD from Cambridge University in England. Now, folks, in our last program together, we told a fascinating detective story about how astronomers discovered that the universe had a beginning. And in this program, we're going to look at the work of Stephen Hawking and how his work reinforced the conclusion of a cosmic beginning. But then, how Hawking and other scientists attempted to get around his own conclusion, though ultimately to no avail. Let's first review, Stephen, some of the discoveries that first led astronomers to conclude that the universe did have a beginning. I'd like you to start with Edwin Hubble. What did he discover that really started things in motion?
Right. Well, as we discussed in our last episode, Hubble was able first to determine that there were galaxies beyond our own Milky Way, and then secondly, that the light coming from those distant galaxies was being stretched out in a way that gave it a redder color than it should otherwise have. It's called the red shift. The light was red shifted. That indicated that the galaxies, and indeed the universe, was expanding in all directions of space, that space was actually being created or expanding as the galaxies receded away from us. And then thirdly, that he discovered that the further the galaxies were away, the faster they were moving away, which implied something like a spherical expansion of the universe, like a great balloon being blown up. But then if you wind that picture of the universe backwards in time, at any finite time in the past, the universe would have been smaller and smaller and smaller. The galactic material would have been closer and closer and closer together, and eventually you would get to a point where you couldn't back extrapolate any further, where everything would have converged to a point that marked the beginning of the expansion and arguably the beginning of the universe itself.
How small did one of the fellows say that it would have to be? He called it what, pea-size?
Well, we'll get into that when we talk a bit more about Stephen Hawking, but in addition to the observational astronomy or astronomical evidence of Hubble, there was a parallel development in theoretical physics that was a consequence of Einstein's new theory of general relativity, because Einstein's theory implied that massive bodies curve the fabric of space or space-time around those bodies. And that, for Einstein, implied that there must be some other force at work that accounts for the empty space around bodies. Because if the only force that were operative in the universe was gravitation, then all the different massive bodies would move towards each other. They would curve space around that clump very tightly, and you'd end up with a giant black hole. But we don't live in that kind of universe. We live in a universe with empty space between the planetary bodies, and therefore there must be a countervening force that's pushing outward. Einstein called that the cosmological constant. On its face, it implied a dynamic and expanding universe. Though Einstein for a time attempted to circumvent that conclusion, he later accepted that the universe was expanding outward and did have a beginning. And those two lines of evidence, the evidence supporting general relativity and the evidence of observational astronomy, were synthesized by the great Belgian physicist Georges Lemaitre, and that became known as the Big Bang Theory.
All right. But let's talk about theoretical physicist Stephen Hawking, who built on Einstein's ideas to provide further support for the idea that the universe had a beginning. He didn't want to do that, but that's what he ended up doing.
Well, it's a fascinating story, actually, and it's told nicely in the little film, Theory of Everything, about Hawking's life.
And I would say it's also told beautifully in this book, folks, that we're going to be offering, Return of the God Hypothesis. Just came out. Stephen wrote it. It's over 500 pages. A lot of people that are in this book, you know personally, and you've interviewed them. What I love about it is the clarity for the layperson who wants to know, what is general relativity? What is special relativity? How is it developed? What were the implications? And when we get to what we're talking about right now with Stephen Hawking, you lay all of this out beautifully, and I'm just saying it's a very, very valuable book. That's why it's a bestseller. So continue from there.
Thank you, but it is a wonderful story about Hawking. He's a grad student at Cambridge doing his PhD in physics in the 1960s, the early 1960s. And he, of course, becomes afflicted with ALS, the Lou Gehrig's disease.
Lou Gehrig's.
But he decides, after some personal reflection, to continue. And during his PhD years, he comes up with an idea that applies Einstein's theory of general relativity to our understanding of cosmology, of the origin of the universe. And he realizes that if Einstein's idea is true, that massive bodies curve space, then as the universe is expanding, as we know it is from the observational astronomy, then space is getting less and less curved because the matter of the universe is getting more and more diffuse. But then he begins to think about, well, what would the condition have been like in the universe at any progressive point back in the past? At each point, the matter would be more densely concentrated, and therefore space would be more tightly curved. And as you go back a million years, a billion years, eventually, however far back you go, you're going to reach a point where that matter is congealing into that starting point, but at that point, space is going to be getting really, really tightly curved, and eventually you're going to reach a limiting case where the density of matter is so compact and space is so tight that space goes to an infinite curvature. And an infinitely curved spatial volume corresponds to something that's so small that you can't put anything in it. It corresponds to a zero spatial volume, which is now what physicists call the singularity, the point from which the universe sprang forth. What Hawking did was very technical. He solved something called the field equations of general relativity in order to prove that this singularity must have been the starting point of the universe. The universe must have started in a singularity of zero spatial volume.
And what were all the ingredients that went back into this little singularity? You got matter, you got space, you got time. What else was back in there?
Well, the idea really intuitively or philosophically, if you think about it, is that once you get to a point of infinite curvature, then you're also to a point of zero spatial volume. You have no space into which you can put anything. And so the picture of the origin of the universe based on general relativity and the solution of Einstein's equations by Hawking and later in collaboration with George Ellis and Roger Penrose is a picture that implies the universe coming into existence out of literally nothing physical, like the old medieval theological concept of creatio ex nihilo, creation out of nothing. And so this was mind-blowing, and Hawking realized that if this were true, this had powerful anti-materialistic implications because prior to the origin of matter, space, time, and energy, there would be no matter, space, time, or energy to do the causing of the origin of the universe. Therefore, if you want to have a causal explanation for the origin of the universe, you would need to think about something that transcends those domains of matter, space, time, and energy. You need to posit an entity which is not bound by space and time and which is not material. And to a lot of scientists, that sounded an awful lot like God, especially when you consider that there is an abrupt change of state at the beginning from nothing to everything that exists.
Yeah.
And that suggests a volitional act, that what would be required to explain the origin of the universe from that point of singularity would be an entity that transcends matter, space, time, and energy, and which is capable of exercising volition to cause a change of state.
Yeah, go through
Now,
that a
if you
little slower again. Why does there have to be an intelligent designer that transcends space, time, matter, and everything?
Because prior to the beginning, because remember, it's time itself that begins.
That's hard for people to grasp, but the fact is true.
It's actually also a biblical concept.
That's right.
Concept, interestingly. But in any case, at the beginning, matter comes into existence. Energy comes into existence. So you can't invoke pre-existing matter or energy to explain the origin of matter. That's a contradiction in terms, because by origin we mean where it first began. So before that, you cannot offer a materialistic explanation. The universe has to be explained by reference to something which is not bound by time and space, and which is not material or energetic in the physical sense.
Let me ask you this. Why did Stephen Hawking not like his own theory?
Well, Hawking realized the profound theological implications of the discovery. It wasn't a theory, it was actually a proof. It was a mathematical proof of the existence of a singularity. It was predicated on the truth of general relativity and the observation of an expanding universe.
Right.
But assuming a few conditions like that, it was a very solid proof in mathematical physics. And he realized that this was, and this is brought out in the little film, The Theory of Everything, about his life, that this had profound theological implications. And he was much more inclined towards a materialistic or atheistic worldview. And that became very apparent late in his life when he actually wrote some of the books that are part of the new atheist genre. But he had this kind of internal tension over this. And so eventually he formulated another theory, which goes by the name of quantum cosmology.
Mm-hmm.
And
what is it?
Well, this is based on the realization that we can only back extrapolate with the universe so far. That when the universe becomes very, very tiny, then what are called quantum effects. Quantum physics is the physics of the very weird that applies to the very smallest realms of our physical experience.
Can you remember the number that you put in your book?
When the universe was 10 to the minus 43rd of a second old, after that point, we could understand it solely by applying general relativity. Before that point, the physicists have suggested that we would need to take into account quantum effects. The weird world of the quantum, where the most elementary things act like waves and particles at the same time, and things like that. And so inside that realm, the physicists weren't sure that general relativity would apply, and that there might be a different kind of gravity acting in that tiny little smidgen of space and that tiny little bit of time after the beginning. And so Hawking and a colleague, James Hartle, at University of California, Santa Barbara, first developed a theory of quantum gravity or quantum cosmology in 1983. Hawking later popularized it in 1988 in his little book, A Brief History of Time. I was fortunate enough to hear some of the lectures which were the basis of that book. And Hawking's version of quantum cosmology attempted to eliminate the singularity. It was only for popular consumption, where he conveyed the idea that maybe you could get rid of the beginning. But in his technical work on quantum cosmology, he presupposed with Hartle a true singularity at the beginning.
Yeah.
But the idea was, if we can get rid of the beginning, then we don't need to worry about what could have caused the universe to come into existence.
Thousands of Christians take cruises for their vacations. So why not take a cruise with John and Darlene Ankerberg? Enjoy a prophecy and end times event conference on the water. And when you set sail with them, you'll experience exciting ports and activities, along with uplifting times of worship, Bible teaching, and fellowship. It's more than just a vacation. It's a time to be inspired, refreshed through the study of God's Word, and reconnect with loved ones and friends. So call or go online for more details.
What I love about your book, I got this idea from your book, is that before you got everything back to the singularity, which is less than a second, it's the number that you're talking about.
It's a tiny, unimaginably tiny fraction of a second.
It's so small, you can't even believe it.
And that's where quantum cosmology comes in. But everything after that, you show, has design with it. Okay, we're going to talk about all the different areas that has design. So you have the universe that we're in, that we know about, and that one says there's an intelligent designer that did it all. The guys didn't like that one. So they went to a theoretical idea, not real universes, but universes that they made up with mathematics about what was in this tiny space of time that happened, that there's no universe that we've ever seen like what they're talking about, but they made it up with theoretical mathematics.
Yeah, well, let me make a run at explaining this. This will be the hardest thing we talk about in the whole series we're doing, but I think we can get the main ideas across. And that is that in order to describe gravity in that tiny smidgen of space just after the beginning, and in that tiny bit of time where quantum effects would have been important to take into consideration, Hawking and Hartle and other physicists attempted to bring together ideas from Einstein, his theory of general relativity, his idea of gravity, with a kind of quantum idea of gravity. And they developed an equation that would kind of describe all the possible universes that could come into existence out of the singularity. And also, in so doing, describe how gravity might have been functioning in that early part of the universe. And they believed that if they could solve that equation, and if their solution implied that a universe like ours was a possible or reasonably probable outcome of all this mathematics, the mathematics of quantum physics, then they would have explained the origin of the universe without reference to a transcendent, a God hypothesis.
Right.
Okay? And this was very much in the background of everyone's thinking.
Right.
And so that was what was attempted. And there have been two versions of quantum cosmology. One which, at least for popular consumption, claimed to eliminate the singularity, and that was Hawking's version.
Right.
And another version that assumed the singularity, affirmed the singularity, but claimed that the origin of the universe could be explained from literally nothing physical by reference to this mathematical apparatus of quantum physics or quantum cosmology.
And you got some slides there that go through the list of what came out of nothing. Do you want to put that up on the screen?
Well, let me just kind of jump to the critique of this, because it's very interesting. First of all, in both Hawking's version and in an alternative version of quantum cosmology that was developed by the Russian physicist Alexander Vilenkin, in the technical work, the singularity is still there. In the popular book, Brief History of Time, Hawking talks about a no-boundary universe where he gets rid of the singularity, but he admits that this singularity only vanishes in an intermediate step of his mathematical depiction of space-time, and only in the domain of imaginary numbers, which have no application to the real world.
Hypothetical.
So he says he actually admits this is a mathematical trick, and that when you convert from the real, back from the imaginary domain to the real domain, the singularity reemerges.
That's right.
So he doesn't actually get rid of the singularity, and you see that in his technical work. I've read the papers, okay? So the first critique of quantum cosmology is that you still have a beginning to deal with. It doesn't eliminate what people hope to eliminate by exploiting that tiny loophole right after the beginning.
Right.
The second critique is that the explanations for the origin of the universe offered by the quantum cosmologists are explanations by reference to a mathematical domain, by reference to a set of mathematical equations. They're not yet describing anything physical. It's a domain of pure mathematics.
Right.
And yet mathematics, we know, is conceptual. Mathematical equations are ideas.
Another way of saying that is, what do these numbers mean when there's nothing else except just the numbers?
When there's no universe to describe.
Right.
And we know from experience that ideas, including mathematical ideas, only exist in minds. So even if quantum cosmology is true, it implies that the ultimate explanation for the origin of the universe is a domain of mathematical ideas that must exist in a mind. And so they come right back to the God hypothesis via a different route.
Right.
Now, to underscore that, let me share a quote from Alexander Vilenkin, who is a profoundly deep philosophical thinker and great physicist who developed one of the two types of quantum cosmological theories. And this is what he says about this very problem. He says, does this mean that the laws are not mere descriptions of a reality and can have an independent existence of their own? In the absence of space, time, and matter, what tablets could these laws of physics have been written upon? The laws are expressed in the form of mathematical equations. But if the medium of mathematics is the mind, does that mean that mind should predate the universe? And of course, I've argued as much in my book. Volinkin throws this out as a hypothetical question, never comes back to answer it. But it's clear he's thinking very profoundly about this problem. And Hawking himself tumbled to the same insight. In The Brief History of Time, he said, what puts fire in the equations that gives them a universe to describe? It's one thing to have a set of mathematical equations that describe all the possible universes that could exist. It's another thing altogether to explain how the universe came into existence so those equations can become applicable. The equations don't bring the universe into existence. All they can do in the best of cases is describe the possible universes that might exist.
Yeah, and I hope that folks understand what you're saying, because even the fact of their ideas referred back to some intelligent mind that came up with the idea. Okay? So you're back to a mind that developed the idea.
They inadvertently prove what they attempted to refute.
Right.
And the God hypothesis comes back in through the back door if you study quantum cosmology carefully. And there's one more aspect to this, kind of a kicker. And that is the mathematical apparatus that they developed to describe how Einstein's view of gravity and a quantum view of gravity could work together, and which also was developed to describe the possible universes that could come into existence, only renders that mathematical apparatus in a very important equation can only be solved in such a way to imply that our universe is a likely outcome of all of that if the physicists themselves fiddle with the equation in a very particular way to get the outcome they want. They have to fine-tune the mathematical apparatus to get a solution to the key equations that implies that our universe is a likely outcome. But that seems to me to be modeling not just the existence of a mind, but the input from a mind of information or intelligence into the system. Because that's what their own minds are doing. It's the physicist who fiddles with the math to get the outcome that they want that makes it look like our universe is likely. And so that, I think, is just modeling the need for an intelligent designer to bring the universe, or in particular a universe like ours, into existence. So again, they've inadvertently proved the very thing they meant to refute.
Folks, thanks for joining me today, and I hope this is fascinating to you. I just love it. In our next program, we're going to look at the issue of fine-tuning. So in the world that we do live in, the universe that we are in, we're going to talk about how physicists have discovered that the fundamental physical parameters of our actual universe are extremely fine-tuned against all odds to make life possible. Why? Do these discoveries suggest the work of an intelligent designer? Right now, I hope that you have enjoyed this, but please stay tuned because I got a personal word for you.